Hello everyone. In this video, I'm going to explain the conservation of linear momentum on the basis of collisions of true spherical balls. Here is the law: if the net external force on a system is zero, the linear momentum of the system remains constant. Then what is conservation? First, conservation means in physics, for a conservation of something, it means that its quantity does not change, or we can say it remains constant. So the linear momentum of the system remains constant, or the linear momentum of the system remains constant. Then what is the system? Hmm. What is a system? A system is a body or a set of bodies under consideration. It is a body or a set of bodies under consideration. Then what is the net external force? Net external force is the resultant force acting on the system. It is from outside the system. Here it is zero. The net external force acting on the system is zero. It means no external force is acting on the system. Here we consider a system of true balls. In the system, we have true spherical balls of mass m1 and m2. The balls are A and B. This is before collision. u1 is the initial velocity of A, u2 is the velocity of B. They are moving in the same direction. They are moving towards right. And we consider u1 is more than u2. u1 is more than u2. Here, A moves faster than B. So, A will hit B. This is the collision. A hits B and B pushes it back. After collision, the speed of each object changes. The speed of the velocity of A changes to v1 and the velocity of B changes to v2. Here we have the momentum m1 u1. Then what is momentum? Linear momentum. It is nothing but p. P is the momentum. It is m into v, mass into velocity of the body. The momentum is mass into velocity of the body. So the linear momentum of A at this state is m1 u1, m1 into u1, and the linear momentum of B is m2 u2. They are initial momentum. Then the total linear momentum will be m1 u1 plus m2 u2. This is the total linear momentum at the initial state. Total initial momentum. Okay. And what is the final momentum? The final momentum of A is m1 v1, mass into velocity. And the total momentum of B is m2 v2. m2 v2. And the sum is the total momentum of the system. This is the total momentum of the system. And this is also the total momentum of the system. This is the total momentum, total initial momentum of the system, and this is the total final momentum of the system. According to the law, the linear momentum of the system remains constant. That means the total initial momentum must be equal to the total final momentum. We are going to prove it in this video. We want to prove this equation. Total initial momentum equals to total final momentum. Here we can see that this is the initial momentum of object A. This is the final momentum of object A, that means there is a change in the momentum, change in momentum of the individual body, but the total momentum does not change. The total does not change. The individual momentum changes. The total momentum does not change. That is the law. Now let us try to prove it. According to Newton's second law of motion, we have the force. According to Newton's second law, we have the force is directly proportional to the change in momentum Pf minus Pi by T, the rate of change of momentum. Here Pf, final momentum, will be the momentum of each body at the final state. Here Fab and Fba, we have two forces. Fab is the force acting on A, and this is the force acting on B. Here Fab is the force on A due to B, and Fba is the force on B due to A. Force on B due to A. This is force on A due to B. Force on A due to B. So it pushes in this direction. Force on B is along this direction. So let us consider the first body. The first body A. The force on A is Fab. So let us write Fab. From this law in SI unit, we can write F equals to final momentum minus initial momentum. Final momentum mv, initial momentum mu divided by time. Here, what is the final momentum? Final momentum of A, here F on A, so we have to consider only A. The final momentum is m1 v1. Final momentum m1 v1 minus initial momentum, that is the initial momentum m1 u1. m1 u1 divided by time t. Here time t is the time during which the velocity changes from u1 to v1. It is also called the time of impact. It is also called the time of impact. It is the time during which the velocity changes from u1 to v1 and also u2 to v2. Now let it be equation 1. Let us consider the second body, the ball B. Force on B is FBA. Let us write FBA. FBA is the rate of change of momentum. Rate of change of momentum will be the change in momentum divided by time. What will be the change in momentum of B? Change in momentum of B is final minus initial. That means M2 V2 minus M2 U2. M2 V2 minus M2 U2 divided by time. Let it be equation 2. Here the time T is the time of impact. And also from Newton's third law, we have these forces are action and reaction. They are equal and opposite. So we can write FAB is equal to minus FBA. Then what is FAB? FAB, putting the value of FAB and also FBA in this equation. Putting the values of FAB and FBA in equation 3, we get FAB is M1 V1 minus M1 U1 divided by time. It is equal to M2 V2 minus m through u through divided by time. But we have negative sign. This is FAB and this is FBA. FBA is minus. So let us put a bracket. T and T can be cancelled. So we have M1 V1 minus M1 U1. Breaking the bracket, minus into plus is minus. So M true V true minus into minus is plus. We have M true U true. Changing the positions of the negative signs. This M1 U1 negative sign goes through this side and it becomes plus. And this M2 V2 comes through the other side and it becomes positive. So we can write M1 V1 and this comes through this side plus M2 V2 equals to this M1 U1 on this side, M1 U1. It becomes positive plus M2 U2. Then we have the required equation. That is M1 U1 plus M2 U2, M1 V1 plus M2 V2. That is the total final momentum. Total final momentum. And this is the total initial momentum. Here we have proved that there is no change in the total momentum of the system, even if the momentum of the individual body changes. The total momentum of the system does not change. Then here is the law. Thank you.